Hi, it's Mr. Baumgarten, and this is the next in our series of videos doing the Coding Quest practice round. Today we are going to survey an asteroid belt. Now this is a fun question that requires a recursive algorithm that's going to work on this two-dimensional array, and it uses a technique known as depth first search. You could also use breadth first search. Well, I'm going to demonstrate it using depth first search. And so it's one of those kinds of problems where if you know the algorithm, then you'll be able to solve it really, really quickly. And if you don't know it, then you could be in for a world of hurt. And it's the sort of thing that really tests your understanding of recursion. So let's get into this and see how it would go about solving it. So I've created a copy here of the example array in a Google Jam board just so I can walk through the process. Now I'm going to iterate over the two-dimensional array by row and then by column, and at every point along the way I'm going to check to see if it's part of an asteroid. And if I find that that individual cell is part of the asteroid, then I'm going to pause my iterating through the columns and the rows and explore and figure out and count up the figure out the size of the asteroid. So what do I mean by that? So I'm going to start here, so row 0, column 0, right? And any number that's a 0 is not part of an asteroid. And we know from our question that the asteroids are joined either vertically or horizontally, not diagonally, right? So this 0 is not connected to this 3. And that the example specifically included, like over here, that this 86 and this 7 were separate. So let's just, my Wacom is not really doing what I want here. Okay, let's just isolate out the individual asteroids first of all, shall we? So this is what I'm going to need my code to find. There's one there, there's another one there, there's one here, and then there's one down here. These are all connected. There's this one by itself, and then there's this one here down the bottom. Okay, so those are my individual asteroids. How am I going to get the code to find them? And so 0, that's not an asteroid. 0, that's not an asteroid. 2, that is an asteroid. Right, so I'm going to have, so it's going to be a double for loop, one through all the rows and one through all the columns, and then I'm going to be like, okay, if it's not 0, then this is an asteroid, and then so then I'm basically, I might even make it as a function, explore this asteroid. Get the, I need, what do I actually need for each asteroid? I'm still on, where am I? Here, I'm not on Wordle, I'm on survey an asteroid belt. But I will go back to running my local copy so that my answers don't go on to the real leaderboard. Okay, so I need to total them up based on the size of the above recruit, the various asteroids, and so I need to find the mass of each asteroid. And then in this, and I've got a nice spelling error here, 8 asteroids, 68 units, average mass. Okay, so once I need the count of how many asteroids I've got and how big each of them are. Okay. So I need the 2, 3, 3, 1, and 1, and I need to add those together. All right, so if I know the 0 is not an asteroid, I know that. So let's explore this asteroid. Basically, the way that I'll do this is when I find a value that I know is in an asteroid, then I know that the asteroid might have values to the right, and it might have blocks to the bottom. But it might also have values to the left, not on this initial one, right? Because the initial one, because I'm coming in from the left, I know that initially going to the left, that's just going to be a 0. Same as because I'm coming down by row, I know that initially I'm not going to have anything above me. But once I'm here, for instance, there's no guarantee that this 0 is a 0. That could have been a number, right? And so this could have all been interconnected. And so when I come in here and I check to the right and I check down, I still need to check to the left. Or what happens here if that was a 0, but this one here wasn't a 0, right? If this one here was a number, then by the time I come down here, I need to check to the left, and then I still need to be checking up. So I can't ignore my left and up coordinates either. So what I'm going to do is I might as well it's easier to code just to check all 4 sides. Right? Check my left, my up, my right, and my down for any particular cell. And if it's a 0, then I ignore it. If it's not, and if it's invalid, right? If there's no up or there's no left or what, then I ignore it. But if it's not a 0 and it is valid, then I need to count it, and I need to then go to it and have it check its 4 sides. So this is where the recursive nature comes in. But if I've already been to the 2, I don't want to be checking the 2 again. So I need a way of knowing which ones I've already visited and already counted, so that when I'm at the 3, I don't then check my left again and go back to the 2 and then bounce back to the 3 and back to the 2 and be stuck in an infinite loop. All right, and so this is where, when you're searching, Googling depth first searches, you will see that they often describe keeping a set or a list or an array of visited nodes, keeping track of which places you've already been, so that so that you don't revisit them. Right? And so I only visit a point that is not 0, is valid, and has not already been visited. And then I can explore all the way through it. That's so, right? So if I come into the 2, let's walk through this clockwise, starting from 12 o'clock for every point. Right? So I start with the 2. Is there one above? No. Is there one to the right? All right. So working around clockwise. So we'll just, for every individual value, we'll just run around clockwise like that. Okay. So is there anything and then we'll just keep a list of the values that we have uncovered. Right. So we've uncovered that there's a 2 in this asteroid. Anything above it? No. Anything to the right? Yes. Is it a valid cell? Yes, it is. Is it a 0? No, it's not. Have I been there before? No, I haven't. So this 3. All right, so now visit that cell. So I now come across here and I indicate that, okay, I've now visited it. So I'm going to add it to my visit list somehow. I'll come back to that later to make sure I don't revisit it. And I go through this same process again. Anything above me? No. Anything to the right? No. Anything below? Yes. Have I been there before? No. So let's go there. Okay. I'm going to go to the 1 and I indicate that it's a place that I've visited. Okay, and my visit list could just be keeping the XY location pairs. I could just be checking the set pairs of coordinates each time if I wanted to. All right, so now I'm exploring 1. Is there anything above? There is. Is it a 0? No, it's not. It is a valid address. Like, have I been there before? Yes, I have, so I won't go there again. Anything to the right, there is, but it's a 0. So I know that that doesn't count, so I'm not going to go there. Anything below, there is, but it's a 0, so I'm not going to go there. Anything to the left, there is. Let's go left. All right, so now I'm here, and I'm going to add this to my list of places that I've been. Anything above, there is. It is a valid place, and it's not a 0, but it is on my previously visited list, so I'm not going to go there. Anything to the right, there is. It's not a 0, it's a valid cell. It's not off the edge of the board, but it is in my visited list, so I'm not going to go there. Anything below, there is. It is a valid cell, and it is not in my previously visited list, so let's go there. All right, that's an arrow. And all right, we are now at the 1. All right, anything above? Yes, there is. It's a valid cell, but it's on my previously visited list, so I'm not going to go there. Anything to the right? There is, but it's a 0, so it doesn't belong to my asteroid, so I'm not going to go there. Anything below? There is. It's a valid cell, a valid XY location, but it's a 0, so I'm not going to go there. Anything to the left? It's a valid cell location, but it's a 0, so that's not part of an asteroid, so I'm not going to go there. I've done a lap of all the locations around this one, so I'm now going to exit this one. And then my recursion is going to exit that, and I'm going to come back to the instance where I was checking this 3. Right? I had been up, I had been to the right, I had been down, and now I need to check to my left. It's a valid address, but it's a 0. It doesn't belong to this asteroid. So I've now finished my loop of the 3. So I'm now going to exit the 3. Back to the 1. All right. I had previously checked the above, to the right, to the below. I just exited coming from the left. So now I'm going to exit that 1 and return back to that 3. All right, the 3, I checked above, I checked to the right, I checked below, I now check to the left. That is in my previously visited list, so I'm not going to go there. That's the full lap done. I now exit the 3, return to the 2. All right, the 2, I had checked above, checked to the right, and that's where we've just come from. So now let's check below. It is a valid cell. It's not a 0, but it is now in my previously visited list, right? Because I had visited it there. So I'm not going to go there. And now I check to the left, and it's a 0, so I'm not going to go there. And that is 2. That's all of them finished. I have finished checking, walking through and checking all the values for that asteroid. And now I know that I have conclusively found all the cells that make up that individual asteroid. And so now I can sum them together and know that this particular asteroid is 2 plus 3 is 5 plus 1 is 6, 7, 8, 9, 10. This asteroid has a size of 10. Right, how am I going to code that up? Because we're 15 minutes in and we haven't done any programming yet. But there's a bit of an explanation of depth first search. So let's see what we've got here. Well, we've got nothing here yet. Okay. Let's put the Wacom out of the way and grab this. Okay, day 3 input. Day 3, we're surveying the asteroid belt. Okay, with open day 3 inputs, read the file as F, And this is just a two-dimensional grid. I'm just going to use the Python list generators. Oops, hang on. f.read split lines. Let's make sure that that works. What have I got? Dot txt. Okay, there's my two-dimensional grid. There's the first row, there's the second row, there's the third row, and I've read it in as integers instead of strings. Okay, so for y in range, so for every row, for every column, if this grid location is not 0, then I need to explore it. So let's put that off in a function. All right, it's going to receive the grid and the y and x locations. And for now, I'll just have it return a 0. And I need the number of asteroids. So total sizes and total number. So then total sizes is just whatever's in there plus this asteroid. Total number will just be increased by 1, and then I should just be able to print out the average as total sizes divided by total number. Yeah, let's just do that for now. I think it has to round, but we'll come back to that. All right, so at the moment, so we explore an asteroid. At the moment, this is going to re-explore the same asteroid every time it encounters the cell. So we need to also make sure that this has not been a previously explored asteroid. We can use our visitor list for that. So we need to make sure, is this y and x location, has it been visited as well before we explore it? But I'm actually thinking there's a so the proper way of doing depth first search is to have this visitor list that we keep building, but in this case we can actually be a little tricky. If I change, when I visit a cell, if I change its value to 0, then that will mean I won't visit it again. Because if a cell equals 0, then I don't go to it. So if I grab its value, add it to the size of my asteroid, and then change that particular cell to 0, that would stop me from revisiting it. And it means I don't need a second data structure that's keeping track of my visitor locations. So that might be the way that I do this. So how would I explore? I mean, I'm tempted to make up a visited list anyway, just to kind of show you how to do it. But yeah, when I did this for myself, I just changed the values of the cells to 0. So if it equals 0, and if the yx not in visited, then we'll do this. Let's do it this way. I might regret it because it's not the way that I did it a month or so ago. So I'm definitely coding on a whim, which is doesn't tend to work for a good video. All right. So I know I want to explore the up, right, down, and left of every cell. So the size of this particular asteroid is what's at my current YX location, plus it is what is at my location 1 above me, plus it is at my location to the right, plus it is, let's close this out of the way, what's below me, plus it's what's to the left of me. Okay, and then I'll return the size. And that is the essence of the recursion, except there's a problem with this. It doesn't make sure that the move is valid, that I'm going to a XY location that exists. So as soon as I try to go off bounds of the array, it'll throw an error. And it doesn't make sure that it's a spot that I haven't already visited. So I'll just keep bouncing back and forth between the same squares endlessly until I get a recursion error. So I need to put those checks in. Now, I can put those checks in before I try going off to a location, or I can do it when I come into an explore. So you are asking me to explore this particular cell. Okay, is this cell valid? So is the y greater than 0, and is the y less than the length of the grid? Then is the x greater than 0, and is the x less than, actually greater than equals to 0, less than the length of this particular row? And is the xy location, hang on, I'm doing yx down here. So if the yx not in visited, then let's explore it. But before we explore it, we're going to add it to visited so we don't revisit it. And if we fail any of those checks, we're just going to return that the size is 0. So size will only get set. Well, hang on, we're not checking that with 0 as well. So if we're a valid y location, if we are a valid x location, and we haven't visited here, and it's not 0. That's all the checks that we need. Let's see what this does. Let's get this to print. Found asteroid. Is it? It's OID, isn't it? Font size. $10. Yeah, there we go. Okay, we knew that first asteroid was 10. That worked straight away. There we go. 8.5. Is that what the answer was here? Yeah, the average mass of 8.5, which can be truncated to 8. So yes, we do need to round it. Okay, so let's just print average not round. We need to truncate it. Not rounding. Okay. 8. Yeah. Let's see if it works on the real data. Copy. Paste. $33. That, I think that's the correct answer. There you go. This is Mr. Baumgarten signing out.